to give his welcome address.
Thank you, Dr. Abhishek. Uh, Very good evening, distinguished delegates, ladies and gentlemen. The Institute of Engineers India Tripura Research Center is organizing the technical webinar on blockchain technology opportunities and key challenges and applications under the aegis of Computer Science Engineering Division Board of IIT Tripura Research Center. So today, this webinar, actually, symbol of this webinar is one of the most growing digital technology is the blockchain technology. Blockchain has the potential to define like finance, healthcare, digital securities, manufacturing, logistic, retail, and other distributed system, etc. Blockchain is becoming a new foundation of all the transaction in the society nowadays. The distributed ledger technology is taking and digital economy towards a new generation of the internet, actually, where people can exchange valuable digital assets such as identification of information, property, currencies, etc., in a trustable manner and decentralized manner. So without the involvement of centralized transaction management securities structure like we have a bank, stock exchange, and governmental agencies. So thus improve living standard and opportunities to the new communities. So it also increases the security of the system. So the immutable, distributed, and easy verifiable property of blockchain makes it acceptable for different solutions. So still blockchain technology is the early growing phase. So further technological developments are also needed to bring blockchain technology to be developed or deployed in more and more and the use cases. This webinar aims to focus on opportunities, the key challenges, and the potential uses, all use cases for efficient utilization of this technology. So today it gives me immense pleasure to welcome all of our panelists on behalf of Institutional Engineers Tripura Research Center. Professor P.L. Chitra, Professor Department of Computer Science, University of Madras, and for our kind consent to be one of the panelists or expert speaker today. We are very much fortunate that you have accepted our invitation in spite of your busy schedule. I also welcome Professor Gautam Shah, Professor Department of Information Technology, Northeastern Hill University, known as NEHO, Shillong. It's a rare opportunity, sir, to have you amidst us. I also like to welcome our Professor Sudipta Roy, Professor and Head, Department of Computer Science and Engineering, Assam University. It is an honor to all of us to have you as particularly as a special speaker today. I also like to welcome our moderator. Today's moderator is Dr. Abhishek Majumdar, Assistant Professor and Head, Department of Computer Science Engineering, Tripura University. Today he will introduce all the panelists before our audience. I, on behalf of Institutional Engineers Tripura Research Center, want to acknowledge the effort of our chairman, Dr. Shubhadeep Bhattacharya of IIT Tripura Research Center. So I'd like to welcome all the honorable past chairmen, past honorary secretaries, past joint honorary secretaries, state committee members, council members, and of IIT Tripura Research Center. Also, all the engineers, faculty members, and officers, students. This particular event, webinar, in this particular evening. So again, this is actually burning topic, blockchain technology, opportunities, key challenges, and applications. So I also offer thanks to our Dr. Jitendra Saxena ji, Director Technical in charge, and also Dr. Kingshuk Sen, Assistant Director IEI Headquarter, and his team for constant support to convene this particular technical webinar. This is actually a approved program, continuing the professional development program, which is approved by the Institute of Engineers India Headquarter, Kolkata. So my request to all the participants today's evening So you should keep equipped yourself in sufficient knowledge or information that will be delivered by our expert speaker today. I extend my deep appreciation to our IEI for their constant support and guidance. So I wish fruitful hours of interesting technical session. With this, I conclude my welcome speech. And over to our moderator, Dr. Abhishek. Thank you.
Thank you, sir. Today, as I have said earlier also, we have three speakers, Professor P.L. Chitra, Professor Gautam Shah, and Professor Sudipta Roy. And regarding the speakers, our first speaker, panelist, Dr. P.L. Chitra, is the professor in Department of Computer Science and Engineering at Madras University. She has more than 32 years of experience in teaching. She has been serving as organizing chair and program chair of several international conferences and program committees of several international conferences. Her research interests include image processing techniques, big data analysis, medical image processing, deep learning models, and network security. She has published more than 130 papers in national and international journals with 213 citations, 9 H index, and 9 I-10 index. Our second panelist, Dr. Gautam Shah, received his B in Electrical Engineering and ME in Electronics and Telecommunication Engineering from Calcutta University in 1984 and 1989 respectively. He received PhD degree from Indian Institute of Technology, Kharagpur in 2000. He got postdoctorate research experience from IIT Kharagpur and Ben Gurion University, Israel. He worked with RE College, Durgapur. Presently, it's NIT Durgapur, India, as a lecturer. He worked in EC department of KGEC, India. He worked with Curriculum Development Center, NITTR Calcutta, as assistant professor. He worked as associate professor and head of IT and CSE in GCELT, Kolkata. His domain of research interest is system biology, bioprocess engineering, and Internet of Things. Presently, he is working as professor of Department of Information Technology, Northeastern Hilly University, Shillong, India. He has published many national papers in many national and international journals and conferences with 599 citations, 14 H index, and 23 I-10 index. Our today's third panelist is Dr. Sudipta Roy, who received his MCA and ME from Birla Institute of Technology, Mesta, and Jadavpur University, Kolkata, respectively. He received PhD degree from Assam University, Silchar. He is Director Research Development Cell of Assam University, Chairman Institute Innovation Cell of Assam University, and Head of Department Computer Science and Engineering, Assam University. He was the Dean of Tribhuvan Sen School of Technology, Assam University, Silchar from 2015 to 2021. Other than different administrative responsibilities, he has also completed 3 externally funded projects. He has supervised 24 students and published more than 150 papers in international journals and conferences. He has edited 5 books. There are 3 patents in his credit. His research interests are network security, artificial intelligence, image processing, and sensor network. Number of citations of his research work is 1244. His H index is 15 and I-10 index is 29. So welcome, sir, all of you, and madam, you have given us time. Now I'd like to request Professor P.L. Chitra to share his views regarding the blockchain technology. Ma'am,
thank you.
You may start.
Yeah, thank you for your nice introduction, and I'm happy to participate. I'll share the screen. Am I audible?
Yeah, ma'am. Yeah, you're audible.
So I'm happy to participate in this wonderful evening regarding blockchain technology, opportunities, key challenges, and applications of IEI technical webinar hosted along with Tripura University. Dear participants, I'll give you the introduction about what is all about blockchain and what are the different types of blockchains available, opportunities, key challenges. And let us go with that. If you have any clarifications, you can stop me at any time and we can have an interactive session. So with this, I'll introduce what is a blockchain. A blockchain is a growing list of data blocks that are linked together. So this is a way you have the data reference, then link to another data reference and data reference. So the general idea behind the blockchain is to cut the middleman, direct transfer of Bitcoins, and we have a lot of cryptocurrencies. All these things are coming under this blockchain technology. So the main aim of this particular blockchain technology is all about building consensus. After a finite time, all participants agree on a single state, example, on one who owns how many Bitcoin, like this. Creating witnesses. If something is published on a public blockchain, all participants become witnesses. This is used, for example, by origin stamp to create a secure timestamp for documents. Timestamp is nothing but a block address that has to be computed based on cryptographic algorithms for each block. Key features of blockchain technology are write-only, immutable, that is, it cannot be changed, transparent, data storage, decentralized, no need for intermediaries, consistent state across all participants, resistant against malicious participants. This is one of the very important features. Then open to everyone. Challenges in blockchain technology are energy consumption, scalability, money laundering, personal responsibility. So let us see what is the meaning, right? Blockchain has many meanings. So let us see, take a phone. The idea of a phone network, a specific phone network, example, Airtel, right? A specific use of the phone network, fax, right? Similarly, blockchain, the idea of blockchain, the specific blockchain that underlines Bitcoins or another coin offering, Bitcoin or another cryptocurrency. So with this, we have just understood what is a blockchain, and we are going to focus on what are the different types of blockchains present in the scenario. So they are basically two. One is permissionless, another one is permissioned. So it can be classified into public blockchain, hybrid blockchain. Then we have another one is private and consortium. As the name implies, public, no central authority is controlling. Hybrid, controlled by one authority with some permissionless processes. Then in the case of second one, permissioned, private, controlled by one authority, then consortium, controlled by a group. These are the ways we can work with our blockchain. So let us look at what is a public blockchain. How does it go? So the first type of blockchain technology, distributed ledger technology. It removes centralization, including less security and transparency. So this distributed ledger technology store information, distributing it across peer-to-peer network. Its decentralized nature requires method for verifying the authenticity of data. This is more important based on mathematical structures, based on crypto algorithms. It is possible to make it decentralized nature with respect to blockchain. That method is a consensus algorithm. That is, a group of people can have an agreement through which participants in the blockchain reach agreement on the current state of the ledger. So it can be done through proof of work and proof of stake are two common consensus methods. Let us look into it in next slides. So public blockchain is non-restrictive and permissionless. Anyone with internet access can sign on to a blockchain platform to become an authorized node. This user can access current and past records and conduct mining activities. The complex computations used to verify transactions and add them to the ledger. In this blockchain, no valid record or transaction can be changed on the network. Anyone can verify the transactions, find bugs, or propose changes because the source code is usually open source. The use cases mining and exchanging cryptocurrencies like Bitcoin. These are all coming under public blockchain. So let us look at what are the advantages and disadvantages of each category, completely independent of organizations. This is coming under public blockchain. Will still be able to run computers still connected to it. Public blockchains is a network's transparency. Public blockchains are mostly secure. These are the advantages of using the public blockchain. There are disadvantages too. The network can be slow. Companies can't restrict access or use. It is open source and can be used by all the people without any common middleman. If hackers gain 51% of more of the computing power of a public blockchain network, they can unilaterally alter it. So public blockchains also don't scale well. This network slows down as more nodes joins the network. So these are all some of the pitfalls in the first category. So let us see what is all about private blockchain. It works in a restrictive environment, closed network, under the control of a single entity. Much smaller scale, as the name implies, group of people comes under the nodes are limited. Operated on a small network inside a company organization. Permissioned blockchains are enterprise blockchains. Private blockchains may be an example, we can say intranet based or public blockchains internet based. Here also we can list out the advantages and disadvantages of private blockchain. The controlling organization sets permission levels, security authorizations, and accessibility. Limited in size, very fast, since limited nodes are available, can process transactions much more quickly than public blockchain. Here also still some more disadvantages available. The small number of nodes, therefore less security. If a few nodes go rogue, the consensus method can be compromised. Additionally, the source code from private blockchains is often proprietary and closed. The use cases in this category are trade secret management, auditing, supply chain management, asset ownership, and internal voting. Let us look at another type known as hybrid blockchain. It combines elements of both private and public, as the name implies, hybrid. Private and permission-based system alongside a public permissionless system. It is a control who can access specific and what data will be opened up publicly. Advantages of this hybrid blockchain: it works within the closest ecosystem. It also protects privacy, but allows for communication with third parties. Transactions are cheap and fast in this hybrid mode. It offers better scalability than a public blockchain network. So with this, disadvantages also we can list out. Not completely transparent because information can be shielded in this mode. So use cases: medical records can be stored in a hybrid blockchain, cannot be viewed by random third parties, but users can access their information through a smart contract. So with this, we have seen three types, along with one more thing which can also be categorized as consortium blockchain, which is similar to hybrid blockchain. It has private and public blockchain features. The consensus procedures, that is agreement among a group of people, are controlled by present nodes. It has a validator node that initiates, receives, and validates transactions. Member nodes can receive or initiate transactions. So with this, we can also list out advantages and disadvantages of this mode: more secure, scalable, and efficient than a public blockchain network. Disadvantages: consortium blockchain is less transparent than public blockchain. So use cases under this model: banking and payments. It's ideal for supply chains, particularly food and medicine applications. Nowadays, we are having a lot of applications. All this could support this type of consortium blockchain approaches. So let us try to understand what is a distributed ledger and centralized ledger. As BC is concerned, blockchain is concerned, it is distributed in nature. So each node A, B, C, D, E, F, all, there is one ledger. All nodes have same level of access to that ledger. All nodes agree to a protocol that determines the true state of the ledger at any point in time. The application of this protocol is sometimes called consensus, right? Achieving consensus. There are multiple edges in the case of centralized ledger as we have banking and along with the different clients, but bank holds a golden record. Client B must reconcile its own ledger against the bank and must convince bank of the true state of the bank ledger if discrepancies arise. So this is just a small description and difference based on distributed ledger and centralized ledger. Next, let us see how might a distributed ledger work. User initiates transactions using their digital signatures. Then users broadcast the transactions to nodes, one or more nodes beginning validating each transaction. Then nodes aggregate validated transaction into blocks, followed by nodes broadcast blocks to each other. So then we have the consensus protocol used based on the crypto algorithms. Then that has to be approved, then followed by block reflecting true state is chained to prayer block. So with this, we can say, how does a transaction get into a blockchain? So a transaction is requested and authenticated, as we have seen in the previous slide, then followed by a block representing that transaction is created. Then the block is sent to every node, that is participant in the network. Nodes validate the transaction. So here hashing, the nodes receive a reward of proof of work, typically in cryptocurrency. So with this hashing and other available cryptocurrency, crypto data, it will go to the block, which will be approved and it will be added to the existing blockchain. Then update is distributed across the network. Then transaction is complete. This way, blockchain will work. Where might blockchain use cryptography? Initiation and broadcasting of transaction. So basically, digital signatures, private public keys can be used along with that. Then validation of transaction, it could be done with the help of proof of work and certain alternatives. In the Bitcoin and other things, we have proof of work, right? Then chaining blocks, we have hash function. It is helpful and based on that we can work. So the history of Bitcoin also could be seen. In 2008, idea was published. Satoshi Nakamoto, he is supposed to be the proprietor for this technology. Then 2009, start of the Bitcoin network. Then first cryptocurrency stock exchange is launched during 2010. Then 2011, 1 Bitcoin equals 1 USD. Such a way it has been emerged. Then 2013, 1 Bitcoin equals 100 USD. Then value has been increased. Then Microsoft accepts Bitcoin. Then 2017, 1 Bitcoin equals 10,000 USD. At present, 42,360 USD is given in the Bitcoin. So Bitcoin is an application of blockchain technology. Blockchain is the underlying data structure which can be used for many things, including cryptocurrencies. So with this, we have introduced what is a blockchain, then what are the different types and how it goes and how it works. Now let us see a simple Bitcoin ecosystem, a public network in which anyone, including a malicious participant, can participate without restriction. Even though it is not organized by a central authority, it works, as we have already mentioned. So here when we have more participants, more security and increased Bitcoin value based on this Bitcoin ecosystem. So we have plenty of applications which is helpful in this technology. Let us see how it goes. Blockchain technology is a combination of 3 leading technologies. One, cryptographic keys. Second one, a peer-to-peer network containing a shared ledger, a means of mathematical computing to store the transactions and records of the network so that it cannot be tampered. Tamper-proof transactions could be done with respect to this 3 leading technologies. So network types, as we have already mentioned, there are centralized, decentralized, controlled by one node, or it could be subgroups of each nodes. This is coming under centralized and decentralized. Then distributed ledgers, as we know, users are anonymous. According to this, we have pink color, and that will show you the each user has a copy of the ledger and participates in confirming transactions independently. The next case, blue color nodes represents are not anonymous. Permission is required for users to have a copy of the ledger and participate in confirming transactions. So distributed ledgers can be public or private and vary in the structure and size. Public blockchains require computer processing power to confirm transactions, that is for mining. So with this, we have seen what is a blockchain and different types and how it goes. Then let us see the highlights. So someone requests a transaction. Then the requested transaction is broadcasted to a peer-to-peer network consisting of computers known as nodes, like this second case. Then validation. The network of nodes validates a transaction and the user status using known algorithms. Then based on this, a verified transactions can involve cryptocurrency. It may be contracts, records, or other information. Then it will be, once verified, the transaction is combined with other transactions to create a new block of data for this ledger. The new block is then added to the existing blockchain in a way that is permanent and unaltered. This is the highlight of this blockchain technology. Then finally, the transaction is complete. So according to this, we can say that cryptocurrency and other things has no intrinsic value, no middleman, then has no physical form. Its supply is not determined by a central bank and the network. It is distributed in nature. So how it works? We will insist again. A transaction is requested, example, sending money in the first step. Step 2, transaction is broadcasted to network. Step 3, network is validating the transaction using the cryptocurrencies like proof of work. Then followed by step 4, transaction is represented online as a block. Then followed by block is added to the existing blockchain as a step 5. Then finally, after which the transaction is complete. This way, blockchain will work. This is a structure of a blockchain. A block contains a number of different transactions. It will have previous hash, transaction details, nonce. What is nonce? It is nothing but a number only used once for every node. Then hash. So each block has its own hash, transaction details, nonce, and previous hash. So based on this, when the new block comes, it will be added. And this is a structure of a blockchain. So what does a block look like? So for example, in the given transactions, we have block 98, 99, 100, and 101. So if you take 101, it will have the proof of hash, right, work. So here it will have the information about version information, then nonce, previous block, timestamp. So based on this, then we have the Merkle tree structure, it is a bottom-up approach through which we may be able to come out with the techniques hashing, and it will prove transaction IDs list and other things will be there. So this is the hash approach, right? Merkle tree hash. Let us see what is a Merkle tree hash now. So Merkle tree look like this. It is nothing but we have a binary tree format in which root node is called as Merkle root. It is following the bottom-up approach. So in this, we have T1, T2, T3, T4 are transactions. H1, H2 are the subnodes of H12. So then followed by H3, H4. These are all the leaf nodes starting of tree, and it formulates a non-leaf node H34. Then with the help of H12 and H34, we will be having H1234. It should be of even nodes in nature. If it is not even, it will be added one with that. So in the Merkle tree, transactions are grouped into pairs. The hash is computed for each pair and is stored in the parent node. Now the parent nodes are grouped into pair and their hash is stored one level up in the tree. This continues till the root of the tree. So we let us say consensus, and we say some algorithms, right? Mathematical algorithms, crypto algorithms. Bitcoin uses a SHA-256 hash function to hash transactions data continuously till the Merkle root is obtained. So further, a Merkle tree is binary in nature, as I have already mentioned. It should be leaf nodes needs to be even, and in case there is an odd number, the tree duplicates the last hash and makes the number of leaf nodes as even. So with this, we have seen how it works and how it could be proceeded. Then let us see about the generations, the evolution. 2009, Bitcoin has been emerged in the version of blockchain 1.0. It's just a ledger, only simple scripting, not easy upgradable. Proof of work is followed in this. High transaction fees, 4 to 6 transactions per second maximum could be evolved in this Bitcoin. Followed by 2015, blockchain 2.0 has been released as Ethereum, smart contract app, programmable, solidity, then not easy upgradable. Proof of work is followed, moving to proof of stake. So here proof of stake is followed, randomly it chooses the next node and it produces. It not like SHA algorithms. Then resources based transaction fees, 7 to 14 transaction per second maximum. Then blockchain 3.0 version has been introduced as electro-optical system, smart contract. We have decentralized apps, programmable based on Web3 technology and Web toolkit, bug recovery and upgradable, account recovery, delegated proof of stake has been followed here. Then no fees for app used, 1000 to 10K to 100K transactions per second could be go ahead with this, right? So these are all the different evolutions of blockchain. Let us see what is all about smart contract in blockchain. Agreement between two people, that is form of computer code. Run on the blockchain, stored on a public database, cannot be changed, can be sent automatically without a third party. Examples, financial purposes like trading, investing, lending, and borrowing. So with this, let us see what is meant by proof of work and proof of stake. The probability of mining a block is determined by how much computational work is done by the miner. So a reward is given to first miner to solve the cryptographic puzzle of each block. Here, reward is given to the first miner to solve the cryptographic puzzle of each block. To add each block to chain, miners must compete to solve different puzzles using their computer process power. So hackers would need to have 51% of computation power to add malicious block. So therefore, proof of work is nothing but a probability of mining a block determined by how much computational work is done by a miner. So here, based on the cryptographic puzzle of each block, miners must compete to solve different puzzles using their power. So then with this only proof of work will work. It is followed in Bitcoin approach. So the next thing is proof of stake. Ethereum has followed this technique. The probability of validating a new block is determined by how large of a stack a person holds. That is how many coins they possess. Based on that, randomly it could choose. The validator do not receive a block reward. Instead, they collect network fee as a reward. So this is followed in proof of stake. There is no computation as block creator is chosen by an algorithm based on user stack. So hackers would need to own 51% of the cryptocurrency on network, which is practically impossible. So this is nothing but our proof of stake. This has been followed in the blockchain version 2.0. Proof of work has been followed in the blockchain version 1.0. So with this, let us see pros of blockchain. Again, improved accuracy by removing human involvement in verification. So the main idea behind the blockchain is to provide improved accuracy by removing human involvement in verification. So authenticity is approved. Then cost reductions by eliminating third-party verifications. So it is not necessary to go with intrinsic pays and other things. Then decentralization makes it harder to tamper with. So that is the main highlight of our blockchain technology. Transactions are secure, private, and efficient. Transparent technology, efficient, and it provides efficiency and speed. So with this, we could again name some of the examples. First one, blockchain, the different type public blockchains, Bitcoins, Ethereum, these are all coming under public blockchains. Then followed by consortium blockchains, R3, Corda, these are all coming under the financial applications. Then private blockchains, Monax, multi-chain, these are all coming under these types. So let us look at one simple example of supply chain management of how the transaction could be handled without blockchain and with blockchain. As an example, just I'm restricting to my presentation only with supply chain management. It could be extended to a lot of applications. Let us name all the applications and followed by you can explore further. So let us see one simple example of supply chain management before blockchain. Gone are the days when delivery boy is coming and he picks up our order and he delivers. Hi, John, here is your order, just like this. It has been given. So similarly, our customer will be happy with delivery and they will be receiving, right? So then the delivery boy may deliver your order. At that time, maybe the apples which are present in that parcel may not be good, rotten. So I want my money back. Customer is annoying, right? But according to this, it could not be resolved immediately without using blockchain, right? So supply chain management before blockchain, I can't help you, John. I'm just the delivery boy. So he is helpless, right? The delivery boy is helpless. He could not give. The customer, these apples are rotten, I want my money. It could not be solved. This was the scenario earlier. After emerging blockchain, such problems can be avoided with blockchain technology as it facilitates traceability across the entire process of a supply chain management. This is highly useful for the business. So blockchain technology can be used to track all type of transactions in a very secure and transparent manner. So here, blockchain, transparently, it could be, transactions could be done transparently with high security. That is the main advantage. So it can be used to track all type of transactions in a very secure and transparent manner. Some of the benefits are quick delivery. We can trace where the, nowadays we have all applications which follows this techniques, quick delivery, reduces cost, eliminates error. It will be delivered on time without any discrepancy. And if there is any discrepancy, it could be traced. And if anything to be given as a feedback, and it could be traced and we can return back and other things, less human intervention. So this is automatic, right? Based on blockchain technology, it can be tracked and all type of transaction is very secure and transparent manner. Now supply chain management is going on with blockchain technology. Example, we have a form, then storage, then food processing, then followed by manufacturing, then distribution, retailer, and it goes to the consumer. These are the different stages of the supply chain management from farm to consumer. In supply chain management, blockchain provides permanent record keeping, transparency and validation of transactions shared by multiple supply chain partners. So it could be tracked, right? Where if any delay is there or how it goes, everything could be tracked transparently with the help of this blockchain technology. This is the main advantage. So from farm, storage, food processing, we can add on block, right? This could be created, and based on that, we can also make it tamper-proof. Along with, we can also make it secure. Also, we can use the proof of work. Based on that, we can apply the hashing and secure, and it could be added as a distributed, right, network as a node. And food manufacturing, the block has been created for each phase, and it could track. In blockchain, transactions are recorded in a decentralized distributed ledger. So this is example of supply chain management in blockchain. Transactions are recorded as a block. As you can see, farm to storage, we have a block over there, right? So in which we can track it easily as a distributed ledger. With this form, then it could be validated, then it could go to the next stage, storage, then validated, hashing and proof of work. Based on that, it could go with the chain, could be added, block could be added, food processing, then verification, then food manufacturing, distribution, retailer, consumer. So this could be due to which anyone can verify authenticity or status of product being delivered automatically. This is the main highlight of blockchain technology with supply chain management as an example. In day-to-day life, this has been followed. So these we have numerous applications and useful applications to the society, mainly in financial matters, banking, then payment gateways, then cryptocurrencies, crowdfunding, banking, insurance sector, trade finance, legal data when you want to transfer that. So nobody should change it, right? Tamper proof. All these things could be made sure with the help of blockchain technology, sharing economy, then real estate, in whatnot, right? Internet of Things. In all the domain, blockchain technology could be applied, and we can provide a better solution for the society. IT cloud storage. So when you want to share some storage, then everywhere this could be applied and make sure whatever the transactions which has to be reached to the particular person carefully to the and healthcare medical records and transactions, then everything it could be also maintained securely with distributed applications as a decentralized node with the help of hashing, right? So supply chain. In all these places, blockchain plays a vital role. With this, just I am giving you what is all about blockchain and different types and advantages, disadvantages, how it goes, then how the blockchain is emerging, how it is being implemented, and you have seen an example. Then followed by, I would like to bring out some top 5 blockchain programming languages. Python, in which Hyperledger, Fabric, then we have NEO, Ethereum. So these are all Steve. These are all used in our Python. Then we have IDE packages, Litecoin, EOS, Bitcoin, Stellar, so Qtum, then Ripple and Monero. These are all different types of blockchain programming languages. We can work with this. So then followed by, so we have a new economic movement, right? Java, NEM, new economic movement. Then Internet of Things applications, Ethereum, NEO, and Hyperledger Fabric. This could be associated with our Java. Then followed by Solidity. It provides Ethereum assisted smart contracts and other inherited models. Go language is also supporting blockchain programming, and based on that, we can achieve Hyperledger Fabric, Go Chain, Ethereum, and DERO. So these are all available technology. Then followed by, we have .NET, in which also we can go with NEO, IoT applications. In this blockchain programming languages, this could be explored further to make out the hashing and other things. So with this, we can also see an example of how to construct a blockchain system using Python. So basic necessities, one who wants to work with the blockchain technology should have some skills in coding. Then this is integrated development environment, text editors. So basically in Python, we have Sublime Text and PyCharm. Then Flask micro-web framework is available to support it. Then programming language, multi-paradigm could be used. So how do we develop blockchain, right? At first, create the blockchain, then establish the communication with blockchain. At last, integrate the API with blockchain. So this is the way we can construct a blockchain system using Python. I repeat, create the blockchain, then establish the communication with blockchain. At last, integrate the API with blockchain. This is the way it could be implemented. Then followed by key methods for blockchain in itself. This is one call to initialize the blockchain. Register node is another function which is used to record a node to the network, new block of self to build and append a new block in the chain. Then we can use hash block, right, to implement hash function over a block. Then new transaction is another function which is used to create new transaction record. These are all available built-in functions through which we may able to make use of it in our code, and we can create our blockchain and establish and work, right? Hash, valid chain to authenticate the chain. Then proof of work, PO, that proof of work, to apply proof of work, POW consensus protocol. Then valid proof is authenticate block before adding to the chain. These are the key methods for blockchain. I hope I have 2 more slides to go and I'll finish it off. Within this, I have just given you the nutshell of what is all about block structure and example and how it works, right? Block structure, as we have seen, proof, previous block hash, timestamp in unit time, index, transaction list. This is available in the block structure. As we have seen, proof, previous block hash, to go what next, right? Then timestamp in unit time, right? Basically, we need to know the timestamp as an independent address, right? Like this, index, transaction list. Creative research areas and open issues, impact of blockchain in social networks. Then advanced cryptography technologies in blockchain, blockchain smart contract applications, data consistency, transparency, and privacy in blockchain, emerging blockchain models for digital currencies, blockchain for advanced information governance models, blockchain in future wireless mobile networks, law and regulation issues, whatnot, right? Blockchain transaction processing and modifying, collaboration of big data with blockchain network, then public registries, record maintenance and replacement plays a vital role in that blockchain. Blockchain is in Internet of Things applications, security issues in blockchain architectures. These are all open issues and we can work on it and we can bring out some new more techniques based on this. Then accountability, data integrity, and privacy is used in blockchain solutions, new blockchain taxonomies and trust models in government and public services. So this is my last slide, and just give you the security is the most important factor for any blockchain protocol to establish a trustless environment. So millions of data sets are exchanged through blockchain technology, often in a transparent public ledger. So the value of blockchain is based on immutability, that is, it could not be changed, of records, and resulting trust in the truth of records. This is the main highlight of our blockchain. And cryptography, consensus, governance, and many other factors have an impact on core blockchain security. Privacy of users, legal and operational impact must also be considered to build sustainable, scalable, and compliant applications. With this, just we have looked at what is all about blockchain and types and some how it works, then followed by some programming techniques and other things. And we have just introduced one simple example and followed by challenges have been addressed in this. So with this, I would like to conclude my session. If you have any clarifications, we can.
Thank you, ma'am.
Yeah.
Thank you. At the end of the program, we'll take question answer session because
Okay.
Otherwise it will be longer. Thank you, ma'am, for your nice discussion. Nice discussion, ma'am. And ma'am, your discussion on the blockchain technology, different types of blockchains and their usages, proof of work, proof of stake, and how to implement the blockchain also, that was very, very nice. And I think that will be very much helpful for the participants. Now I'd like to request Professor Gautam Saha to start his discussion on the, this blockchain. Sir?
Yes, sir.
Yeah, sir, you can share your screen.
I'm sharing my screen. Yeah.
Yeah, yeah. Yeah, it's
You
visible.
see,
It's
na?
visible.
And
Yeah.
I'm audible also.
Yeah,
Now,
sir. Yeah, sir.
Madam has, thank you, Madam. Madam has told everything about the basics of blockchain. Now, I will just touch upon the basics and I will talk more on the application part of it because I'm working on the application part at this moment, and I will just share my experience with you on the application part of it. Okay, so here, blockchain technology opportunities, definitely the opportunities part I will highlight. Key challenges, we are facing a lot of challenges over here, and its application, different application domains. Of course, Madam also has said many application areas. I will repeat them and try to elaborate how those applications can be implemented, can be augmented, can be enriched using blockchain technology. So, introduction to blockchain is a distributed ledger technology, and it is centralized. It is different from the centralized ledger. Centralized ledger means, as is clear from this figure, that there is central entity who operates everything. Now here it is everybody is doing everything. Everything is clear to everybody. All the ledgers are available to everybody. So blockchain operates in distributed, decentralized system. It's a completely decentralized system. Now, actually, how a blockchain works, also Madam has shown, and I'm also repeating almost the same thing. If a transaction is to be done, say a node raises transaction request, say the transaction is represented as a block. Now the block is broadcast among all the nodes. I'm giving you an example. Say in a bank, in Calcutta, there are 100 banks. So transactions are done in the banks during the daytime operating time. So if one transaction is operated from branch X, okay, so that transaction is that transaction is recorded among all the 100 all the 100 branches transactions list. So it is the block is broadcast to all the nodes of the network. Then the transaction is validated by the nodes. It has to be validated so that it is not from outside. It is not from some. It is not from some source who are not the part of the system, banking systems. And when it is validated, then it is added to the block. A new block added to the block. And here, a transaction is validated by the blocks means a hash function is created. Hash function is created means, see, this transaction when is added to the existing transactions, a hash function means it is a depending on all the transactions, a particular hash function is created by, there are several algorithms for it, and we are using SHA-256 for creating that hash functions. And there are several other hash function creators are there, lightweight, but this is not lightweight. So this is hash function is created and then makes a block along with the transactions and one hash function, and this becomes complete. The transaction is become complete. Similarly, from other banks, if any transaction is occurred, so it will go to this block. The block is broadcast to all the nodes of the network, and the transaction is validated, and a new hash function is created, and that is added to a new block is created to the new hash function, and that is broadcasted among all the nodes, and then the transaction is complete. Say, in between this, where is the problem? Problem is, say, in between the transaction represented by a block. So in between the two banks, if there is a man in middle in the attack, then what will happen? He is not a valid one. So what will happen? He will change the transaction pattern of one particular bank's transaction, and that will disturb the hash function. And that means the banks will see that a particular node has got different hash functions than all other the similar hash functions in other banks. So it will reject it. So that means the man in the middle attack can nicely be tackled by this particular manner. So transaction is created and submitted to the blockchain network. So it is, the transaction is collected and combined as a block. Okay. The block is validated, mined, and broadcast to the blockchain network. The block is appended to form a chain of blocks. The chain is secured by using cryptographic techniques, and the same ledger statement is maintained across the network using consensus protocol. Okay. Now, see, the ledger is available to everybody. So everybody can see everybody's transactions. That may be objectionable. Now it is possible that this transactions is not readable to everybody. Our transaction is readable to everybody. It is possible that we can use cryptographic systems, cryptographic techniques in between, so that whatever is there inside a block cannot be read by the other blocks also. Now, this is cryptographic in blockchain, and it is so asymmetric cryptography is used generally, as I've said, that cryptographies addresses are transaction is done by the digital signature. That means when a transaction, I give a 100 rupees to X, I give 100 rupees to, say, Subhrajyoti. So Subhrajyoti has got that function, and that transaction will be complete when my digital signature system has been verified. So this is transaction is, or digital signature is highly used in this blockchain system. Chaining the blocks, cryptographic hash function is used, as I have already told. Validation is hash tree, so Merkle tree is used, as Madam has shown you, the binary trees. Consensus algorithms are used, that is proof of work, proof of stake, etc. That Madam has already explained nicely. Achha. Now, blockchains are of various types of blockchains are there. Public blockchain, not owned by anybody, permissionless, that means Bitcoin, etc. Anybody can access it, fully decentralized, example, Bitcoin, Ethereum, and private blockchain owned by private entity, and it is always permissioned, no public access. It is centralized generally, and Hyperledger and Corda, etc. These are the platforms for this. And consortium blockchains owned by a group of organizations, it is always permissioned and limited access, partially decentralized, and just like banks, bank chain. That means State Bank of India is maintaining its all its transactions by blockchain systems. It is highly secure. It can be done like that. It is possible to done. Now, I don't know whether it is presently been presently whether they are working in this manner or not. But blockchain can play very beautiful, secured transactions between the banks by using the blockchain systems. Okay, in that case, bank forgery, etc., will be reduced to a great extent. Achha. Features of blockchain: it is decentralized, of high data availability, offers high data availability, and security. Use cryptographic solutions to protect data. As I have told, we are using. We can use cryptographic solutions for protection of the data. That means since the ledgers are available to everybody, all the nodes, immutability, resistance to tampering and manifold, because as I have told that if any tampering occurs in between, the hash function will change. And if among all the broadcasted blocks, if one block contains different hash functions, then that block will be rejected. So it will be treated as a hostile or it is illegal block, and it will be rejected. So that means it is registered to tampering. Transparency is ensure trust and accountability. It's highly, so naturally it is highly trustworthy, and its transactions are accountable. It's programmable, can be scripted using smart contract. Yes, how it is programmable? Say I have purchased one plot, one flat. I have purchased one real estate property. So when I can write a smart contract that when in a real estate scenario, so when this money will come from X to Y, then Y will get the possession of the house, or Y will get the houses. That means the rights to enter the house. So this smart contract will serve that purpose. When the money will reach to X from Y, then and X says that, yes, I have received the money. Programmable, and this can be done nicely using this and securely, very secure. So use cases, store patient's information, medical history. Say in a medical systems, I have got a list of, I have got some medical history. So medical histories are always private. It should not be shared, or maybe limitedly it can be accessible to the doctors, but it should not be accessible to everybody. So how to protect it? Blockchain can help in this type of protection. Okay, so past illness and all these things to protect the storage data against unauthorized access and modification. Similar thing, that means if I have got some data, some classified data, I want to protect it from its access from the another person's. First, I will use some cryptographic functions to protect it, and then I will use the blockchain hash function in the block, so that the same thing can be circulated. This ledger can circulate among the nodes, but each nodes cannot read my data, and outsiders, due to the hash function protection, outsiders cannot access it anymore. To provide access to authorize only to the authorized person, to provide access only to the authorized person and devices. So authorized persons can, if authorized person is, say, if I send some information to Y, so then this to decrypt my that means that information to decrypt from the cryptographic state, then we can exchange the keys. Okay, so that key management system can help in decrypting it, and they can read that means the person or the authorized person can read the information from there. Solutions provided by the blockchain: store the medical stores as a block and secure this using cryptographic hash functions. As I have told you, there are two things. One is cryptography and another is hash function. They can store it, authenticate users before accessing and updating the medical records. Okay, allow the secure sharing and exchange of patient data among the relevant stakeholders, and the patient medical history can be used to identify and predict the possible illness. This patient's medical, now here is the application of AI with the blockchain. That means if a patient's total history is available to me, and if I use any AI tool on it, that AI tool is meant for predicting any future disease that man can generate. So it is also possible. It is also possible, and that particular information will go to the particular person only. So here is the blockchain will give the protection of the data, and AI will help in predicting what particular disease is going to have in future, and it will be transmitted to him in a secured way. Now, opportunities increasing adoption. More industries will adopt blockchain to avail its benefits. Security is the primary reason for which they will try to avail it. Integrate with other technologies. Yes, here I have worked. IoT. IoT is an area where Internet of Things, where it is not getting, it is very nice technology, the communication between things to things, but it is not widespread at present. Because reason is that security is the limitation. Security is the limitations. Now, how to use, how to secure the IoT communication systems? So for which we have used blockchain. Now, in the blockchain, SHA-256 is highly, you can say, computational intensive. Its time complexity is very high. Its space complexity is also very high. Now, IoT systems are very small devices, and it has got limitations, very high limitations of computational power and everything. So SHA-256 to execute on real-time basis, it is impossible in IoT environment. So how to use the blockchain in IoT environment? So what we have done, we have instead of SHA-256, we have used several lightweight hash functions generators so that this can be securely used in the IoT domain. Okay, secure. So, and these things also working, and we got several papers out of it. Secure platform for innovate, provide a platform to design and implement new and innovative solutions. Secure platform means innovation with IoT and the blockchain. It's very fertile area. It's a very, very fertile area. We can develop various products and which you can sell in the market, specifically for military or for not for military, for the areas where security is a great aspect. Say in a factory, say let us think that we want to secure some military installations. Okay, so how the blockchain can help it? So if we give some cameras to the security cameras to the different places of that particular installation and broadcast them to the central house, to a central location, it can be, security can be maintained. But the problem is that if enemy systems come and it starts broadcasting something false to the central room, so it may create some problem. So how to authenticate the cameras, that our designated cameras will only send the images sent by the designated cameras will only go, and unauthorized camera cannot transmit any illicit image to the central room. It is highly possible to using blockchain systems. That means authentications. That means the system. That means things authentications. That means only the authenticated cameras image will be transmitted to the central place. That means our central system. So that means to our central room. So this is a secure platform innovation. So this is also one type of innovations which has got a lot of potentiality in the different sectors. Decentralized applications, promote decentralized applications. It can, that means where decentralization is very, very important. So supply chain management. It is also very much decentralized applications. Here, also a lot of innovations can be done. Say, as Madam has also said, that decentralized means if from the farmhouse up to the person who is using that person, customer. So there are so many persons involved. Say Amazon or Flipkart says the product is coming from the factory, it is stored in a storehouse, and from the storehouse, it is, say, storehouse in Chennai, and I'm ordering it from Shillong. So how it will come? It will come through several spots. First, it will from Chennai, it will come to Bangalore. From Bangalore, it will come to, say, Delhi. From Delhi, it will come to Calcutta. From Calcutta, it will come to Guwahati, and from Guwahati, it will go to Shillong. And everywhere, the mode of transport may be different. Somewhere it can go by plane, somewhere it can go by train, somewhere it can go by taxi. So there are how to protect its safe departure, and so that, and also another thing is that, as Madam has said, Apple has rotten. Apple has got rotten. Possible that in some places, in some sections, so from Chennai to Calcutta, Chennai to Bangalore, Bangalore to Delhi, maybe in Delhi it is happening that somebody has taken away the good apples and put the rotten apples inside the box and again send it. So, and it will be transmitted to Shillong as rotten, and the customer will shout that I have got rotten apples. So how to protect this? That means at Shillong, at Chennai, we'll put some RFID tag on it, and those will be added as an input to the blockchain. Blockchain means to the ledger that will be serve as an input, as one of the inputs. So everywhere, when it is coming from Chennai to say Bangalore, so it's one thing is changed. That means it has changed its location. That will be changing, but the RFID must not change. If from Bangalore to Chennai, both the things has changed, hash function will change. Okay, this is one thing. Another thing is that yes, he can change it. Hash function will change, no problem. Let it change. But when we will trace back why the person has got the rotten apple, then we can find that in Bangalore the hash function has changed due to the change of two particular functions for a box. It should have one particular function should have changed in the transaction level, that was change of location. But instead of that, change of location and the RFID tag both has changed. So that is not that means we can find out that some foul play has been done in Bangalore or Delhi, whatever it has been done. So in this way, it can be traced back nicely. So these whole systems can be traced back also, and all the informations are kept in the computer very nicely, wherever what is happening and what is done. Some vital points, vital records can always be stored into the computer sections, and they are well protected by hash function. Okay, so this is that means here it is. So what I am telling, that opportunities means increase of increasing adoption, integrating with other more industries. So industries were adopting the blockchains for its very good benefits. Integrate with other technologies. As I have told, AI can be integrated with blockchain. In case of medical systems, not only the prescription will be securely kept in the hospital, AI systems of the highest hospital can predict that man may have this disease in future. It can alert that person, or doctors who are next, if the person next comes to the hospital for any eventuality, doctors can see the record and as well as the predictions what can happen to him due to the past history. So he can treat him very nicely. He can treat him in a shorter time. IoT, as I have told already, IoT and blockchain. If IoT can be integrated with blockchain, IoT can be safely used for any banking operations. So banking operations will be much more widespread. Okay. So this is another thing, integration of other technologies into the blockchain. Secure platform and innovate, provide a platform to design new and innovative solutions. Innovative solutions always it can come. Decentralized platform, because I have already told it. Challenges is consensus algorithm. There are several challenges in blockchain. Consensus algorithms. Okay, so sometimes it is very much computationally intensive. Okay, so it may take huge energy, as I have told you that during IoT it is a limitation. So consumption, that it should be lesser computationally intensive, as well as the security should not be hampered, compromised. So it is a challenge. It is a research area. Scalability, required to process a large number of transactions. If the number of transactions is very, very large, scalability will be a limitations. Computational power will be higher. Security and privacy, secure data and ensure privacy of users. Okay, complexity require a high level of technical expertise for its installation and others. Interoperability, no standard protocols or blockchain communication is available nowadays. That is also a challenge. And regulations to prevent illegal activities also a problem. Along with the blockchain, that Madam has said that 51%. If the 51%, if the hacker can manage to overcome it with the 51% of the, say, one transaction is happening, and it can be, if it is confirmed by 51% of the stakeholders, then he will have all the access over the systems. So this is very, very dangerous. Acha. Finance. So in applications of finance, fund transfers, loans and insurance, it can operate very nicely. Government services, land registration, healthcare, pensions, benefits. Here we can use the blockchain systems very nicely. Say pension benefits. Pension benefits means when a person dies, it may happen that the person has died, but he's having the pensions after that also. So how to stop it? Government services. That means, so when a person is died, that means if any particular number is going with, if the particular number is going with him, and that if he is died, the hospital will, it will follow in the hospital also. And so a person is alive or not alive in case of pensioners is also a information. So when hospital reports that person is not anymore in the world, person has expired, so that it will automatically change the hash functions and nobody can touch his pension. That means his pensions will be stopped automatically. So healthcare, land registration is very, very important here, because in the land registration, in case a lot of irregularities are going on, one land can be sold to 8%, 9%. So these things are always happening, specifically in some areas where the land is of premium cost. So to stop it, for making multiple registration of the same land. So this particular hash function or this particular blockchain systems can play a very, very important role here if government is interested to implement it. Now, medical records, I have already told. Real estate means track ownership, transfer of properties. Transfer of properties, as I have already told, this smart contract can play a very important role over here. Supply chain management, track movements of goods through supply chain. This can be regulated. Every movement of the goods can be regulated. Status of the good can also be regulated. If any tampering has done on the good or not, that can also be regulated. And so supply chain management not only will ensure that things are moving in a correct direction, that means the particular movement of the product is going on the right path and the right time. Not only that its quality is maintained, that no tampering has been done in between, that is also been ensured. That can be done by supply chain management. Voting system, very, very important thing. This we are developing. One of my research scholars is working on voting system. They're developing a voting system. That means it is e-voting systems. What he is doing is this. He is making a special type of EVM machine where the voter will come with his card. He will put his thumb impression and eyeball detection, etc., so that he is first authenticated, number one. After his authentication, the EVM machine will allow him to cast his vote. After he has cast his vote, his vote cast will be immediately converted into some. It will be encrypted and it will send to the district level server. So whenever this man has sent it to district level server, even if it is a ledger, public ledger, since it is encrypted, it cannot be, no use to anybody to see it. Everybody can see it, but nobody can understand whom he has voted. Okay. Now, see this particular, there are several districts in a state. So all the districts will record all the EVM machines votes. Okay. So to the state level machine. Okay. Now, when it goes to the state level, so a state's voting systems will be a state's voting systems will be completely, a state will complete the whole state, who is the voting, that is 24 for elections. All the elections results will be stored in the state level voting systems. Now next, what will happen when the voting is finished throughout the India, all the states records will go to the Delhi Central Election Commission. And each level, say district levels, state levels, and Delhi, all of them are protected, data are protected by blockchain. So any outside, say a person has created a voting machine outside and he started casting his vote from there, it's not possible. Any manipulation is not possible. So finally, the day when the counting has to be done, from the Delhi, all over India, the election can be, that means local level counting is not required. Local level counting is not required at all. So from the central place, one central place, the election results can be declared, and it is a very authentic experience. But still, we are in the process. We are working on it. Now, our next phase is that we like to hack it from several sources so that we can prove that blockchain is really it is not possible to tamper the votes. And after that, maybe we will submit the thesis after that. But definitely, I feel the results till now is very, very encouraging. Okay, so voting systems definitely have added. Digital identity provides secure and verifiable digital identities. It is also possible, as already said, by blockchain system. Thank you, sir, very much. So I have said about some very short, I have given some very short lecture today and mentioning some finance, some application parts on it. And we have already worked on voting systems, working on voting systems. We have already done some PhD works on implementation of blockchain on IoT. This already we have done, and we have found that it is working practically. And that particular girl who has done it has already got his PhD degree. And still many things can be done. As I have told, that particular security systems, which or military systems can be highly ensured, a particular military identifications. That means each military can be identified with blockchain secured security systems. Even he can be tracked when he is moving forward in the battlefield. His movement can be tracked, and his health condition can be tracked in that particular condition also. Thank you so much.
Thank you, sir. Thank you for your discussion on working of blockchain. It's some use cases, some opportunities, usages of blockchain in IoT, especially your currently whatever you are working on a voting system. That was, I think, very, very application side of the blockchain, having some real life scenarios and real life application. So thank you, sir. Now I'd like to request Professor Sudipta Roy to start his discussion. Sir, you may start.
Yeah. Already my previous speakers, Professor Chitra Madam and Professor Gautam Saha, who are the pathfinders of these blockchain areas, they have discussed regarding the technology behind blockchain. They have already set up the environment regarding the blockchain applications and the Madam as well as sir, both have discussed the application in different as like us, where security is a concern, blockchain can be used. Now we know all these things. Already we came to know about blockchain and those, and previous Professor Shah identified or informed us that it is under the government, where the government wants to implement, whether we want to be more secure channels or not. That is a question, and that has come up. Now, I will try to penetrate in those areas, mainly relating to healthcare system. So I will try to go through the healthcare system using blockchain and those. Now, the healthcare system is not just a patient's data, is not just any application of the hospitals. It is the consolidation of all the domains of the patient, starting from the disease identifications towards the coming up into the wellness center, and then behaving well in the home, and after rejuvenating, the patient can lead the normal life. So the whole system is my healthcare system. So I will concentrate on healthcare system, and here, though many bullet points are pointed out, but I will just touch only the healthcare vision, and then technology trends, research issues, and use cases. The other portions right now is not needed to be discussed or is not possible into the time frame. So I will skip those portions. The healthcare vision, this vision is the government vision. The vision is to become one of India's largest sector, both in terms of revenue as well as terms of employment. And it comprises of hospitals, medical devices, clinical trials, outsourcing, telemedicine, medical tourism. That is a sector, medical tourism sector, where we need to protect our information through the blockchain is possible. Health insurance, medical equipments, different type of bioengineering, that is come up, and all these are comprising my healthcare system. And as per government of India perspective, we are having two major components. One is public healthcare centers and another is private healthcare centers. Both are working hands in hands in government in India, and we should take all these private and public when we will tell about the healthcare systems. This is the scenario of 2021, where from the total budget of is coming, major is coming from health insurance, other portions are coming from investment, and out of pocket the people are paying 10%. The government public health activities are spending very only if we can minimize the out-of-pocket 10% to be included or to be minimized, then our purpose will be served. And from healthcare, from health insurance portion, Medicare, private health insurances, and all the other health insurances are there. These data are gathered from the Center for Medicare and Medicaid. And this is where it is going. The 100% money invested where? Out of that, hospital care is only 31%. It is decreasing. It is a good sign that the hospital care is decreasing and the allied portions are increasing. Also, the prescription drug in 2016, the expenditure in prescription drugs were more than 10%. In 2021, it has come down towards 9%. That means we are thinking that prevention is better than cure. So we are trying to make ourselves more robust against different diseases. There is a proof, digital proof. And our healthcare total, if we think about the Indian health market, that is growing, and it is projected. Here we have shown from 2020 towards up to the projection of 2030, when we are projected with a graph of increase of 19.3% annually. This is called cumulative annual growth rate, CAGR, that is 19.29%. So it is coming from 20 towards 2030, the vision of government of India to make the market like this, to boost the market like this. And here we can get that number of doctors in India is increased a lot, as well as number of medical colleges. If we cannot increase the number of medical college, the number of doctors cannot be increased. As per WHO recommendation, per 1,000 or less than 1,000 people, one doctor should be available. But right now in India, we are getting 1,800 against 1,800 people, one doctor. If we consider the Ayush doctors and all as per government of India notifications or jurisdiction, then it will come down, but that is not at par with who. We are trying, the government policies are trying its best to carry on those things. Now, this is the health insurance premium collection. Quickly, I can shift towards there so that we can reach towards our goal, that is blockchain. This is the Vision 35, a public document, public healthcare surveillance in India, Vision 2035, where National Ayush Mission is integrated with the conventional healthcare system as well as the public-private partnership. Taking all together, the vision creates 2035 vision creates to achieve the milestone set by WHO. And the aim is to adopt blockchain in several industries. This is the Government of India initiatives. The blockchain framework that is by NBF, National Blockchain Framework, is a document, 52-page document, declared and published by Government of India in December 2021. That means nearly 1 year ago, more than 1 year ago. That 52 page is the starting first phase instruction or Government of India initiative. The aim is to adopt blockchain in several industries, including e-governance, including health technology, including agri, financial, education, and many more. It is having one 5-year plan unveiled by MeitY, the Ministry of IT and Electronics, as part of National Blockchain Framework. It is called NBF. So just quickly, we can go towards that NBF. What National Blockchain Framework is telling. My previous speaker, Professor Gautam Saha, they are working into real field as like voting machine, as like financial aspects. And as a part of government, now government declared, that means government also wants in India to implement blockchain. So that is now confirmed through this white paper, 52-page document. And the policy of NBA is telling it is to build a national scale blockchain infrastructure, to build blockchain as a service, to build geographically dispersed nodes so that staying in Northeast, the people can access, staying in Andaman Nicobar, the peoples can access, staying in Lakshadweep or remotest Jammu Kashmir. The regions, the 4 corner regions that are very, very vulnerable towards the integrated India. The Northeast region in extreme eastern North zone. The southern east zone is having Andaman Nicobar Islands. Though Andaman is much more secured and nearer, but Nicobar Islands still dead. Penetration to Nicobar and controlling Nicobar is very, very challenging task to government of India. The Lakshadweep, extreme west south corner or West Arabian Sea, Lakshadweep is a vulnerable point. And all we know, in north, we are having Kashmir. So, to build up geographically dispersed nodes and their protection, what Madam Chitra and Professor Saha told previously, that security issues, if we can protect, then digitally we can give protection to our vulnerable geographical locations. For that, we have to build awareness to our people, to our users, to local people. We have to build human resources, because without the building the human resources, who will use blockchain? How to use blockchain? How to create? How to work? Till that, blockchain is in the research domain, as like Professor Saha iterated. The PhD scholars are working. The industrial people, very few, like IBM or some, they are working, but not implemented to all. We have to create. Let's see future. So, government of India is trying to promote BICA. Just my previous speaker iterated that the hybridization of AI and blockchain, hybridization of IoT blockchain. Now BICA has come, and it is the terminology used by government of India. A convergence of blockchain, IoT, cloud, and AI. This is my BICA. B for blockchain, I for IoT, C for cloud, and A for AI. Sorry. So this BICA is coming up as a policy, government policy, and now we can work in this domain. The researchers, the industry can work, and we are free to carry on our implementation. What is the benefit of this promotion? We will be ready for global use within 5 years of the strategy's implementation, because the NBF first target is for first 5 years from 21 December towards 26 to get certain advancement in blockchain. Then we will think. And government of India initiation towards healthcare industry. So the government of India initiation, they are thinking that to establish national blockchain portal, though it can be implemented everywhere, but today I am thinking about healthcare only. The government or GOI intends to establish geographically dispersed blockchain infrastructure, is to keen to establish onboard MSMEs and startups. Another revolution that the government of India has taken. The revolution to carry on works with MSME and startups. MSME is Ministry of Small, Medium Scale Industries. And we should create cross-border applications so that we can integrate all. To do that, we have to standardize the India stack for the adoption of blockchain and integrate blockchain technology with the majority of national services. This is the motto of government of India. to carry on blockchain initiative. Now we are coming towards healthcare industry where advantage India is pronounced everywhere. The developed countries, the American countries, North America and USA, as well as the superpower of European countries, they are respecting India due to certain reasons. It is not like that all are respecting India in true sense. No. They affect to us due to our youth, due to our softwares, due to our brains to work with AI and blockchain. And here in healthcare, we are in advantageous position. After Corona, during Corona, we looked that our policy, our people can work a lot. I am quickly just passing these things. This is not required right now. We do not have much time. In latter phase, sometimes we can do. And technology trends. Now, these are the technology trends already pronounced by my previous speakers, where we can use blockchain in IoT, already told, in robotics, different type of robotics, in 3D, in augmentation reality and smart centers, and our future technology that comes up with blockchain, where global blockchain market that is forecasting, global blockchain market is forecasted by 2026 as a market share of $91 billion, with a growth rate of cumulative annual growth rate of 43%, unimaginable. That's why the government of India, just in the beginning of 2022, though the document is showing that the NBF is declared in December 2021, but actually it has come up in 2022, and we want to penetrate into that zone, that global blockchain market. And this is the global blockchain adoption across healthcare application, where in 2017, the 50% of the industry, healthcare industry, were not sure or no plan about the implementation of blockchain, whereas 35% were in dilemma, though they were having the production proof, and 15% were commercially deployed. In 2020, the commercially deployment has increased a lot. The production proof has come up to 45%. So automatically the no plan area, no plan zone is reducing. And in 2025, the projection is something like this. The 55% commercially deployed area will be there. That means we can generate huge employment, huge scope of work in healthcare domain of blockchain, with a 39.5% of undergoing work, undergoing projects, only leaving minimal portion of medical sector, that is my healthcare sector. The barriers of blockchain adoption in India already different accounts are pronounced, so I am speaking. And these are the advantage of blockchain in healthcare, where for patients, the medical history right in the pocket and direct access to healthcare, I can get it. For healthcare organization or insurance companies, they can have that cost saving by having a more complete picture of a patient's health. And for healthcare professionals, they can get the data sharing platform wherefrom they can get the personalized medicine. P7 is my future healthcare system concept, where personalized is one. So personalized medicine, personalized treatment is coming up, and we have to go to, because a daily wages treatment plan cannot be same as like the treatment plan of any industrialist. of any billionaire. So the personalized treatment plan is required. For blockchain can help the patients, the patient parties, can help to the organization and companies, can help to the healthcare professionals as well. So all parties are in win-win situation. Now we are quickly running towards the innovation part of blockchain. That is the research part. Already we are nearing towards the time zone. So innovation is the concept where streamlining physicians' work, optimizing systems, improving patient outcomes, reducing human error, or lowering costs, all are coming up. And that we have to implement in different fields of healthcare system. Healthcare means, I told, including everything up to rehabilitation of any patient. The challenge, the healthcare scenario, now at this moment, the healthcare and pharmaceutical industries are lagging behind, where only 7% of healthcare companies, hospitals, and other companies, they are using automation or blockchain. Only 15% of pharmaceutical companies are digitized only, but we have to carry on a long path. So what we can do with blockchain? With blockchain, healthcare organizations can capture an individual's lifetime medical history. The privacy can be maintained via permission blockchain. As told, the permission blockchain is first lecture Madam Chitra pronounced. So these permission blockchains can be used here to protect privacy of the patients. The confidentiality can be maintained. And to maintain doctor-patient privacy parties, that also possible. Quickly, I can go to the end slides so that we can have that EHR and those. Now we can manage all these things. We can manage the consent of the patient. We can manage out of country care. We can manage clinical trials. The tracking of clinical trials, not only clinical trials, but also the trace route of the drug, that can also be found out easily using blockchain. The prescriptions can easily be digitized, and we can manage bundled payments. Bundled payments means more than two parties, two providers, service providers are altogether bundled. Suppose I am going to one hospital. Hospital told for certain different investigations from any specialized hospital. All these can be bundled together and payment can be done securely from one point. That is possible. Now, this is the last conceptual point that I will tell today, and then we can conclude because already it's 7:50. We are defining the health persona, the personal record in healthcare. It also comes from my previous speakers' discussion, where through the logical sensors, from fitness tracking sensors, from physiological sensors, we can get the data. Physiological sensors, we may have the smartwatch, we may have mobile phones, we may have different type of inhaler systems, wherefrom we will gather the physical data like my BP, my temperature, my SpO2. Sorry. So those, those can be captured from my physiological sensor. My fitness tracking sensor can give certain data, as well as the logical sensor can give me my location, the environmental factors, as like whether the environment is having a greater sense of moisture or not. Today, dust particles are huge or not. What is the condition, local condition? So those things are available from the logical sensors through GIS or other sources. These three sensors are generating different data. For a particular patient, the health persona is combination of all those, where we can get the food events, what foods I am consuming, what type of kinetic events I have taken, and what are the physiological events I have executed along with my life events, and all together these are saved into the personical database, where from we will get my health persona. And how a health persona can be converted, can be related to a personal healthcare record, PHR. Let's find out. This is my PHR, where electronic health record along with my genomic analysis will give my PHR, a personal health record. If we can keep the personal health record ready to us, the P7, the key factors of the healthcare system can achieve. So this is the personal health record creation, PHR creation, in very short, in very lucid way. I am trying to give the overview, though in each and every point there are the hurdles, the implementation hurdles. India is a vast country with 130 crores people. Creating PHR is a huge work. We have to work. The scope is huge. As the problem is huge, the scope is huge. And it's a challenge for us, because Government of India already disclosed the national blockchain framework. Now it's upon the technology people, the people like us who are working in different forefronts, to carry on that baton for our PHR, for our regular health records. This is the structure already told by my previous speakers, because these things are very, very sensitive blockchain implementation, and we are coming towards the end of that, where we can implement blockchain. And I can conclude with these things that our smart healthcare, the healthcare system can be smart enough using PHR, the personal health record. And for that, blockchain is proven to be an effective tool. It is proved. It is a proven effective tool in preventing data breaches, improving the accuracy of medical records, and cutting costs. If we can implement towards the 90% of my hospitals and healthcare service organizations along with the patient data, we can cut down cost much more. When a patient from Northeast, when a patient from Kashmir, or when a patient from Lakshadweep or from Andaman is going towards Chennai or Delhi for a super specialty hospital service, they will get it easily using that PHR, because the super specialty hospitals are getting PHR record with the consent of that patient, and easily those patients can be treated in those super specialty hospital. This is the, I am reaching towards that endpoint. And thank you all for listening. This is my major themes of blockchain in healthcare, and this is the acknowledgements where from all these slides are prepared. Thank you. Thank you all.
Thank you, sir. Thank you for discussion on the usage of a blockchain in a healthcare system with the examples. You have also discussed about this Government of India guidelines for usage of blockchain in different fields. So it was a very helpful discussion for the participants, I think. Now we have actually a few questions typed in the chat box. So first question is how to use blockchain technology in reducing energy consumption in wireless sensor network. Any of our panelists can answer the question.
Actually, we have done work on it because IoT system is I can say in the wireless sensor network is one sort of wireless sensor network. And I already has mentioned that these devices are suffering from resource and energy constraint. So they have got computational limitations. Now, how to reduce it is that how to reduce the computation. Simple. First is that the energy is consumed, resource is consumed because the computational power requirement is high. So if I can make the algorithm shorter, that means that and in the blockchain, what is the basic algorithm which takes much of the computational power is SHA function, SHA-256. So there we are reducing it to lightweight hash function generation. So we have developed certain lightweight hash functions also, and there are available many. And we have used a suitable hash function, that means lightweight, so that energy consumption and resource requirement is highly reduced. So this is the only way which I have done, and it has given some remark. Now the question is that if you use lightweight hash function, security will be compromised, obviously. 256, and we are using low, that means from 16-bit to 4-bit. That means there has to be some optimization, okay, or there has to be some other techniques. So random function generation, random number generations. So you say every 3 milliseconds, you change the random number generation algorithm. So in that way, the hackers cannot track so easily, it cannot break so easily those particular lightweight hash function systems. Okay, so in this way we have managed judiciously that how we use lightweight systems, as well as it will protect our device. So our mobile phone, this mobile phone is also uses this security. Every 3 seconds they changes the algorithm, security algorithm. Okay, so even the monetary transactions can also be done using this mobile. And mobile phone is one of the subset of IoT. Okay, so this is how the energy consumptions can be, within the energy consumption can be minimized. I'm not saying that. I'm saying that energy consumption can be limited to permissible level, so that the block function can be implemented on it on real-time basis.
Okay, thank you, sir. One more question is there
actually,
from Dr.
Yes.
Yeah.
Actually,
yes, sir, you can tell.
this energy consumption part, Gautam has already worked a lot, but the issue is till date issue is open, because we had to go a long path regarding energy consumption as like the mobile phone. So whoever is questioning, they can jump into that portion to carry on research on that. It is possible.
Exactly.
We did not reach towards the end. So carry on. You dig your head, the concept, the things you already got from Professor Saha. Now put your head there. Start that work.
Yes.
Thank you, sir. One more question is there, Dr. Murugesan. He asked that regarding industrial applications, how to integrate IoT Industry 4.0 with AI, robotics, with blockchain technology.
One is medical application. Medical application means along with the storage, providing the security to the data storage or limited security bit, restricted security, I will rather to say. It can, with using the data, using the AI tools like graph set theory and others, which are rule-based, they can predict this man has got these symptoms, this medical history. So this man has got this probability, such and such probability to that disease may occur to him. This is one AI application on it. Okay. Apart from this, say a soldier is moving. He's residing in very remote areas. Through IoT is connected to his base stations. And you see them in the US military systems, they are their body is full of equipment. So many gadgets are put to his body. What are they? Apart from the military equipments, there are also health gadgets are there in his body. So what it does, it all continuously tracks its health parameters. It continuously tracks its health parameters. Say if any particular action requires tremendous amount of energy from his side, then what it will be said that the command station will say that your health condition will not permit you to do so. You just keep behind. The persons who has got the good health condition, they will recommend them to proceed. So this is one parameter. And if they see that if they see in military operations in those countries like America, where I'm speaking about any country's name, these European countries or these countries higher the so-called rich countries, manpower is very precious. So they cannot afford that a soldier should die so easily. Okay, so if he sees that a soldier is in stress, in physical stress, so immediately he will stop there. They will just send some military ambulances or some sort of helicopters to carry him out from there. Okay, so these type of things are highly possible using that IoT systems. If IoT systems is completely private, these are all private IoT. These are all private blockchain systems, not private IoT. I will say private blockchain systems. Okay, IoT is also is not very safe all the time because IoT is having IP addresses which are hacked, generally which are hacked. So you hacking these IP addresses, our enemy can know our positions. So I am also doing some research on IP addressless communication, IoT, where this communication can be performed without IP, using IP address. That is called ICN, Information Centric Network, or NDN, okay, Name Data Network. These are the new techniques, very, very new technologies which has come. So what I am telling that this is the solution. This is what I am like to tell to you, that it's innovation. It is innovative techniques are this. Innovative technique means you can earn your money, you can earn your startup. You can, if you can develop such a systems for the military gadgets, that using least amount of instruments on the body of the military, you can identify them, is my military. And second, if that gadgets are taken away by some enemy, the stamp will not be, the correlation stamp between the ECG graph and EEG graph will not be same. So we can easily understand that his gadgets, his diet, and he's in danger, and his gadgets has been used by somebody else. Okay, so these are the security aspects, very much high security aspects, which can be used by military in the operation field. So this is also a good, and DRDO is wanting this. DRDO is presently wanting this. There are several things which DRDO want in the security aspects, deadly want, highly they want, and these things nobody give to another country. One country, if he's developed this thing, he will not give it to others. The drones, we are also ICN, when you are working with ICNs, we are using cluster of drones. When a cluster of drone is going to attack one particular place, say I am going to attack my country X. So that country X will just send one drone into that club, and it will give misinformation to the whole lot of the drones that you go back and attack the source. So it will come back and attack India. So how to check that this is a intruder drone? Blockchain technology will work. We are using blockchain-based security systems, key generation systems, so that any intruder into the host of my drones can be detected nicely, and its information will be rejected as simple as that. Okay, these are the very, very primitive things which you can develop for defense. security aspects. The defense is suffering
sir.
from security problem.
Yeah, another question. What is the impact of blockchain mining in global warming scenario?
Global warming scenario, yes.
Yeah,
I am
global
not
warming
very much
scenario.
competent.
What
Madam can
is
tell
the
it better, or
impact?
sir can tell it better.
Yeah, madam.
Mining, yeah, mining means it is computational or brute force attacks, is not it, madam? It is mining is basically those boys. One of my research scholars is doing this. I'm always rebuking him, but his hobby, he's like this, not hobby, I will say he's addicted to it. He has purchased so many computers, and it is so intensive. Shillong is a very cold place, so that's why he required less amount of this air conditioning. But those persons who are using this thing in Silchar or in Calcutta, they may have to use huge amount of high air conditioning for running those machines. For
it is
Madam can tell
required
you
much more for madam, because Chennai is too hot than us also.
Yes, madam can tell it better. I'm not competent in mining. I know little about it.
So we have done some work based on drone communications, and we are working on it with respect to security aspects, then anti-drone detection. I think as Professor mentioned, we could add on this techniques, blockchain. With that, I think we can provide security. In this dimension, we can think then unmanned aerial vehicles, wherever it is required to transfer. Then we are also working with dual level security scheme for image encryption. I think image encryption, we can transfer steganography and something like that. We can crypto, and that aspects could be add on with respect to blockchain technology. I think global warming, we have to think about it, right? That temperature collections and other things, and due to weather forecasting and other things, we can think about the blockchain techniques. I think we can do research further to add on to have a meaningful applications which may help the society and national level and international level. I think this will have to be taken as a good step to think about global warming. Is there any possibility of making use of this blockchain techniques with respect to global warming technologies? So basically, blockchain, we have worked with some Polygon-based applications, just like SHA-256. We have worked with some algorithms based on Polygon-based, and we have applied, and we have made that as a energy-saving first proof of work algorithms like that.
Yes.
I think we have answered.
Thank you, ma'am.
Quantum computing is the solution. Quantum computing is the solution, I think. Madam.
Yeah.
Another question. Another question we have. So, which company is leading in working with blockchain technology?
Which company is leading? Oh, I don't know.
Yeah.
Maybe there are a lot of scope for India.
Yes. Actually, the companies are jumping towards this. Mainly now the blockchain and quantum. These two factors the companies are trying to get in, though some companies are telling they are having AI team. But AI team, the implementation is going towards blockchain. They are not telling exactly blockchain. Now, after 22, the companies are revealing they are working blockchain, because government of India do not have previously the blockchain, the authentication or the authorization. Now, the companies are revealing they are going into it. All the companies right now having their research front, their research wings on blockchain, on quantum, and quantum AI is coming out. So quantum inspired AI that can be built into blockchain to give the solutions. As Madam told, as Professor Saha told, the drones or wherever security, wherever encryption is required, we can use it just like a list, just like a note, and we can use it. The processing in the core field will be my AI. When quantum will come, the processing will be through quantum AI. Let it be. It is the processing, but the structure, the architecture, blockchain, that is possible.
So multi-dimensional
thank you,
data
sir.
could be handled, sir. Multi-dimensional data could be handled with quantum computing comfortably with the blockchains.
Yes.
Thank you.
And
If any of the
and there's a
participants can ask the
secretary.
questions.
Secretary sir is here. Secretary as well as moderator. Our tea or coffee is pending. I am taking at home. Sometime we will have this tea and coffee all together.
Right, right.
So
It's a nice
virtually
discussion.
provided, sir.
Okay.
Yeah, it's a pleasure. So we have got one platform. So we are
Right.
still we are having some of the queries still we have. So moderator, I'll request you can send me email so they can discuss.
Yeah.
And one of my queries I have that is actually the blockchain is not new, but in India we say concept is we are using like different projects, real life projects like mining projects, agriculture projects, and some real estate projects, beverages projects, different projects we are using. So what is the actual future? I don't know what exactly we are going to have this kind of, how we can handle those different, the sir already told that P7 is a healthcare is a very good things, like we can have a personalized medicine and all. So healthcare system is growing, but in other projects also, this is also growing rapidly in blockchain technology. So this will be helpful. We will especially, properly utilize the blockchain technology.
Yeah,
Another very
ultimately,
important thing, which I have got an aim to take in my future research, railway protection system. Okay,
Right.
railway sabotage. That means that recently there is one accident of Coromandel Express which has costed 300 lives. It's a sabotage. So there are similar sabotages also happened in Jalpaiguri just after the Siachen Glacier fight. That means that what is called Kargil fight. So these are sabotages and high-tech sabotages. So these sabotages can be safely, nicely, easily be avoided if we can properly use blockchain systems into it. By just not only I have got plans of hardware how to solve this problem. That is so that if these two trains come on the same line and sabotage, both of the drivers are thinking that I will collide these two planes, suicide square, and I will kill I will destroy something of my interest. Possible. Now, this is not possible because if the blockchain comes and if the data cannot be traced back due to the blockchain protection, in that case, when using IoT, if this information is known to, if this information goes to both the trains, driver has got nothing to do. The train will stop automatically. The engine will stop. Engine will automatically stop. This is number one. Fire in the compartment can be known using IoT systems. This departation of the compartment from the train can easily be understood, and it can be taken out. Taken care of. Another thing is reservation systems. Reservation systems can be very easily done. It can be manipulated. It can be manipulation protected using blockchain. Very easily it can be manipulation protected because we are already using computers. Okay. So so these are the things which I am thinking in the next PhD, but I don't know, I will require a very good students. I am not getting good students in Shillong. If I get any good students, definitely I will go ahead with this. And this will
Thank you, sir.
Whenever we need tamper-proof transactions, definitely we can go ahead with the blockchain, sir. Tamper-proof data, and it should be handled carefully with security. Always blockchain is helping a lot. Tamper-proof.
yes.
Tamper-proof. That means if enemy puts another node in our railway systems, that is the problem. So I have to identify this authorization is a strong authorization using blockchain is the prime need. and it should be on real-time basis.
Yeah, now in railway, Cobos has introduced, though it is not blockchain based, but they have introduced AI. With Revise, they are trying to stop that engine, and as per the claim, it is working. Now, if we use blockchain, it will be more robust.
Sir, Cobos uses cloud. Cloud is not a safe area. Okay, cloud is not at all a safe area. So if we can go to fog, VPN, that means private or localized fog computing, particularly for the train systems, that will be the real scenario. We cannot. Cobos uses fog. But first of all, I have to hire cloud, not access, not permissible. I will not give my security to the public domain. Whatever be production be there in the cloud, but we have to use it as a private systems in a fog type of systems of railway's own network. Okay, so it will be highly protected by blockchain systems. I have got the whole architecture I have made ready, but needs to be implemented, not only implemented first in simulation, then while simulation we face so many problems. When we are using voting system, it is the boy is working for last 3 years. And recently he got success in making the whole systems ready in simulation. Now the problem comes performance analysis. How the performance analysis to be done? I am inviting hackers. Please attack it. Ethical hackers. Please attack it. Attack the system as a whole. Where is the loophole? Because if any voting system is implemented, politicians are multimillionaires. They will hire the best hacker of the world to crack it. So the whole system must be almost foolproof. Foolproof is not possible. It is 99.99% foolproof, so that at least it is better than the existing one, at least in West Bengal scenario. So this is what this is what is the behind this research is West Bengal scenario for making an EVM machine, blockchain based, very small machine. If a rowdy person comes and break the machine, no problem, because counting is done from Delhi. Localized counting is not required at all. Cost will reduce drastically. Only thing is that somebody has to come and hack it. Let me see how much it is hacking proof. So I am in search of, I have employed some hackers, and I told my student, you be a hacker first, get trained yourself in hacking, employ all sort of hackings on the network, on the system, see that how much it is proof, how much it is secured, so that at least 2-year level, research level, later on we can go for its perfection. And he is using Ethereum platform, but Hyperledger is the better platform which he failed to implement. Maybe we will do it later on.
Thank you, sir. Now I'd like to request Dr. Minalkanti Debbarma to offer a vote of thanks.
So it was lively discussion today. We have actually very good discussion regarding the blockchain issues, opportunities, and applications especially. So officially I have to propose the vote of thanks. So distinguished guests, delegates, ladies and gentlemen. So the topic we have chosen today, blockchain technology, opportunities, key challenges, and applications, which is organized by Institute of Engineers, India, Tripura Research Center, under aegis of the Computer Science Engineering Division Board, IEI, Tripura Research Center. So first of all, I would like to thank Dr. Abhishek Majumdar, Assistant Professor and Head, Department of Computer Science Engineering, Tripura University. He is the moderator today, and also introduce all the panelists among the before our audience. So thank you, Abhishek. And we have a eminent panelist today. The first panelist, Professor P.L. Chitra, Madam. So I'd like to thank Professor Chitra, Department of Computer Science, University of Madras. On behalf of Institutional Engineers Research Center, I'd like to convey our sincere gratitude to you, madam. Thank you. So on behalf of Institutional Engineers Research Center, let me convey sincere gratitude to our Professor Gautam Shah, Professor, Department of IT, Northeastern Hill University, Shillong. Thank you, sir. And I must mention our deep sense of appreciation, Professor Sudipta Roy, Professor and Head, Department of Computer Science, Engineering Department, Assam University, for inspiring and encouraging with us your words and especially healthcare system in this particular technical webinar. Thank you, sir. I also extend my thanks to our chairman. He could not attend today due to some emergency, Dr. Shubhadeep Bhattacharya, FIE, Tripura State Center, for his enormous cooperation in this organization to organize this particular technical webinar. I'd like to thank all the participants, all the past chairmen, past honorary secretary, joint honorary secretary, state committee members, distinguished corporate members of IEI Tripura State Center and all other centers who has already given the pleasure of their company today in this nice evening. So I also like to thank various honorary office bearers, especially silent workers behind the scene who have ensured the success of today's webinar. Especially Technical Director, Dr. Jitendra Saxena, and also Dr. Kingshuk Sen of IEI headquarters for supporting this webinar. So ultimately, once again, I want to state the most grateful to all the speakers today for this particular webinar and audience, various institutions for attending today's technical webinar. With this, I conclude my vote and thanks, and I think we can conclude today's technical webinar. Thank you, with the permission of other members. Thank you. Good night.
Thank you, sir. So with this, we come to the end of the program. So thank you all the panelists for giving us your precious time, and to the participants, I'd say I think all the discussions were very, very encouraging, and you can explore more possibilities in the field of blockchain, because you can use blockchain in any field. So thank you for everybody. Thank you all. With
Thank
this,
you. Good night.
We are now closing the meeting.
Night.
Thank you.
Thank you. Bye. Good night.
Good night, sir.
So with the permission of all, I would like to end the webinar, if you kindly allow.
Thank you. Thank you.
Okay, sir. Thank you. Thank you, sir. I'll end the webinar.
Thank you very much. Good night.
Okay, sir. Good night.